Haley introduced some aspects of climate change and emphasized that these changes in extremes that where the biggest impacts occur. And so I'm also going to focus on some aspects of that. But I want to give you a little bit more of an understanding of why some of these things occur. And so we have increases in greenhouse gases, and that actually increases the heat that's available because it traps the outgoing radiation. And so what it does is it creates an energy imbalance on the planet Earth. And a lot of my work has been focused on looking at this energy imbalance and trying to figure out what the consequences of that are. So this is a figure dating from a paper in 2009. There's a lot of numbers we can put on here, and I'm just showing a few. These ones at the top of the atmosphere, this is the incoming radiation, this is the reflected, this is the outgoing. About 240 difference here. Remember that number? 239 going out. So there's about 1 watt per square meter that's absorbed, and that's the global warming component, if you like. So if we have 1 watt per square meter, we can compare that with these little incandescent Christmas tree lights. They're about 0.4 watts. So it's about 2.5 of these every square meter. But if you add it up globally, it turns out to be 500 terawatts. That's 500 with 12 zeros after it. And you can compare that with the total electricity generation for the whole globe of 5 terawatts. So this is a factor of 100 greater. And by that standard, you can see how large it is. But it also tells us that the direct effects of humans, for instance, by generating electricity and using electricity, is quite small, except very locally in big concentrations in cities. And it's mainly through this interference with the natural flows of energy that climate change comes about. The second thing we can do with this 1 watt per square meter energy imbalance is compare it with the natural flow, and it's very small. So you can't go outside and feel climate change. Instead, it has to accumulate to have effects, but it does because it's always in the same direction. So one place it accumulates is by melting ice. And Greenland and Antarctica, I haven't included those here, but there's a 40% decrease in Arctic sea ice, for instance. On land, there's a big difference on land depending upon the natural weather that's occurring. If it's wet, a lot of heat goes into evaporation, and that fuels storms. But in the absence of heat, it leads to drying. And in places that have a long, dry summer, continental, a maritime climate, and often in the subtropics, this can happen in Vietnam, we can get an accumulation of effects through the drying and the heating. So 1 watt per square meter over a month, if you just accumulate that, that's equivalent to 720 watts per square meter over an hour. That's how many hours there are in a month. And you, instead of 1 square meter, if we put it, say, every square foot to approximate a small microwave oven, then this is equivalent to 1 microwave oven at full power for every square foot of the planet for 6 minutes. Now, if you ever put anything in the microwave oven for 6 minutes, you've put a cup of water and it boils after, 3 minutes. And so no wonder things catch on fire. So that's a physical argument. Most of the heat, though, goes into the ocean. And this is the record of the ocean heat content. And we're breaking records year after year for the ocean heat content. 2019 is the warmest year for the global oceans for the top 2,000 meters. And that has consequences all around the world. One of the consequences is, along with the glacier melt, is it leads to sea level rise. And so this is the record of sea level rise from altimeters in space. And it's going up at an accelerating rate. Over on the right here, I've got about 75 millimeters. So this is since 1992. And so coastal regions are seeing this effect, and it greatly impacts with regard to any storm surges that occur. I was asked to speak a little bit about attribution, and this is a little bit of an old slide now, but one of the fun things about being a scientist is you can sort of play God. We can run climate models with and without human influences. And when we run it with human influences, there's a whole bunch of climate models on here. They're all averaged out to give you the red line, and the down dips are volcanic eruptions. And the observed record for sea level, for sea surface for surface temperature is the black line. And then we can also do it without the increases in carbon dioxide in the atmosphere and so on. And we get this difference. So this is the climate, well, this is the global mean surface temperature we might have had if there'd been no human changes in the composition of the atmosphere. So global warming has really kicked in since about the 1970s or thereabouts. And so the warming is present in the surface record. More generally, if you look at the effects of that warming and the heating, there's a lot of weather that goes along, which is not predictable. And mostly the best way to think about it is that it would go on anyway. But the environment for all of this weather, all of the storms has changed. And these are the main variables. The temperature is warmer, the water vapor in the atmosphere is higher, as Haley said, sea level is higher. And these are robust and predictable. And this is some of the actual numbers here, and there's some actual curve. This is water vapor over here, and this is 2-meter temperature, sea level, and so on. And so the argument then is that all phenomena are affected by the change in environment. And it's supported by the fact that the oceans are inevitably warmer. And so we see consequences like this. This is just since 2017 of a few examples of some dramatic flooding, and then some heat waves and some wildfires here. I'm not going to dwell on these. We can come back to them if you wish. And then I want to talk a bit about hurricanes. These are some since 2017. There's Harvey, which Haley mentioned, and there's 3 here in the Indian Ocean. There's a couple here over in the Pacific Northwest. And we often get this question asked of us. But so hurricanes are certainly natural, but they're supersized now. And I would argue that these events would not have happened the way they did without the human-induced climate change. And what's more, the preparation for this, so this relates to adaptation to climate change, has been quite poor in many places. In some places, it's actually been good. The death rate in India and Pakistan has been reduced dramatically by the warnings that have occurred over what it would have been 20 years ago. And so these are the main consequences. And with climate change, we expect more activity, more intense hurricanes, bigger hurricanes, longer lasting hurricanes, and more flooding rains. And we've certainly seen a lot of that this year. So I thought I'd give a couple of examples that have affected Vietnam. This is late in October. October was certainly a month which caused a lot of flooding and deaths and damage in Vietnam, but this is getting into November. And so this is a pretty spectacular storm approaching Vietnam. And then I pulled this one off just a few days ago from a bigger perspective. You can see the edge of the planet over here. And this is nighttime. And here's this Vamco, which made landfall. And then this one also in late October, Goni, that did a tremendous amount of damage in the Philippines before coming across to Vietnam. These are the overall storm tracks. And so my understanding is there's at least 7 of these typhoons some of them are super typhoons that have hit Vietnam this year, and tremendous damage in various places. The other damage that's worth noting in dry spells and in the summertime was a good example is last summer in Australia, where they had all of these wildfires. These are pictures from space. And in Australia, they called them bushfires, a record bushfire season. And this past summer in the United States and in the West Coast, there's been a tremendous amount of smoke and wildfires in California and Oregon, and even Colorado had a record number of wildfires this year there. And here's the number, Martin, for an estimate of how much carbon dioxide was put into the atmosphere from some of this. And so these are potential consequences. Vietnam has in the past suffered from some wildfires, and it could happen also in the future. And you've just got to watch out for these dry spells, and that can happen in certain phases of the monsoon. So climate change is happening. It's caused by human activities. The effects are relatively modest thus far. Overall, you might say 5 to 20%, certainly in terms of precipitation. But that means thresholds are crossed and things break, they flood, they burn, people die, and the damage is extremely nonlinear. And so there are storms like Harvey where instead of $1 billion worth of damage, the damage is over $100 billion. And there's been a number of examples like that. And the real cost of climate change is grossly underestimated by economists. So I call this the straw that breaks the camel's back syndrome. So here's my contact information, and I will stop there. Thank you.